Welcome for all students of the third stage in Pharmacy College, Basra University. I am Irfan Al-Asadi, a lecturer of the Pharmaceutical Inorganic Chemistry Lab. It's a good chance to meet you again, even electronically, and we hope safety for all students in the present coronavirus pandemic. We will talk in this course study upon oxidation-reduction reactions, and simply the oxidation is defined as electron loss from a chemical, or proton gain by a chemical, or oxygen gain by a chemical. The preparation and standardization of 0.1 normal potassium permanganate solution is the first lab in oxidation-reduction reactions in the present course study. KMnO4 is dark purple or black powder or crystals. It is soluble in cold water and freely soluble in boiling water. It undergoes decomposition on contact with certain organics. KMnO4 is considered as a strong oxidizing agent, and this imparts KMnO4 a bactericidal activity. This bactericidal activity is diminished in vivo due to the reduction of KMnO4 by body fluids. The potassium permanganate has a deodorizing property and its astringent. KMnO4 can be considered as a self-indicator in titration due to its intense color. KMnO4 has a low cost. The aim of the present experiment is preparation and standardization of potassium permanganate solution. The chemical The procedure of this experiment includes preparation of zero point 0.1 normal KMnO4 solution and the preparation of zero point 0.1 normal sodium oxalate solution, and then conducting a titration between these solutions. First, the preparation of a liter of zero point 0.1 normal KMnO4 solution. Weigh out the appropriate amount of potassium permanganate using a watch glass. Transfer into a 250 ml beaker containing water and stir thoroughly, breaking up the crystals with a glass rod to effect solution. Allow to stand for at least 2 days. Filter the solution through a small plug of glass wool supported in a funnel into 1 liter volumetric flask, leaving the undissolved residues in the beaker. Add more water to the 250 ml beaker and repeat the process several times until all the potassium permanganate has dissolved. In the 1 liter beaker, make the solution up to the graduation mark by addition of water and shake well to ensure thorough mixing. Store in a dark, clean, closed container. Note: the concentration of KMnO4 solution is left known for learning targets, but in a practice exam, the normality of KMnO4 would be unknown, where this is the principle of standardization. Standardization by zero point 0.1 normal sodium oxalate solution. Accurately weigh 0.67 grams of anhydrous sodium oxalate previously dried at 110 degrees centigrade and dissolve it in 100 milliliters of water. Add 7 milliliters of sulphuric acid and heat to about 70 degrees centigrade. Titration. Slowly add the permanganate solution from the curate with constant shaking. The first few drops result in a pink color persisting for about 20 seconds. Wait until the color disappears and then continue the titration with the usual manner. The end point is reached when a faint pink color persists for about 30 seconds upon shaking the flask. Note: The temperature of the medium should not be less than 60 degrees centigrade throughout the titration. The calculation is done using the equation N multiplied by V is equal to Wt over EqWt multiplied by 1000, where N and V is the normality and volume of KMnO4, and Wt and EqWt is the weight and equivalent weight of sodium oxalate. Potassium permanganate solutions are not very stable because of the water oxidation which is present in the chemical equation stated in the slide. Well-prepared solutions are reasonably stable because the decomposition is slow. This decomposition goes faster by the presence of light, heat, acids, bases, manganese, and manganese dioxide. Manganese dioxide is a black contaminant usually present with KMnO4. Also, it can be produced during preparation of KMnO4 solution due to the reaction of KMnO4 with organics probably present in water used in preparation. Preventing the formation of manganese dioxide or removing it by filtration greatly improves the stability of KMnO4 solution. Standing the KMnO4 solution for 2 days or heating it for a short time can contribute in increasing the stability of the KMnO4 solution by oxidizing the organics that usually present in small amounts in water. The paper can't replace the glass wool in filtration because it can react with the permanganate ions forming manganese dioxide. The H2SO4 acid increases the oxidizing ability of KMnO4 and provides protons for the medium. Keeping the temperature near to 70 degrees centigrade throughout the standardization process is important because the oxidation of sodium oxalate is rapid enough at such temperature. Formation of a brown color during the titration is caused by insufficient acid applying too high temperature or the use of a dirty flask. Standardized permanganate solutions should be stored in the dark. Filtration and restandardization are required if any solid is detected in the solution or on the walls of the storage bottle. In any event, restandardization every 1 or 2 weeks is a good precautionary measure. Note: the words in red color are in need for why. Thanks for your listening. I wish you all the happiness.